In this session, we are going to work out on analysis and design of a RCC collar using STAAD Pro V8A software. So now we'll see the problem of a column. So this is the experiment number 2.5 in the manual, analysis and design of a RCC column. So this is the column 3.3 meter long with one end fixed and other end free, carrying a point load of axial load of 300 kilonewton. So we take up the same problem to analyze this column using STAAD Pro. So this is the first screen, as we know. I'll click on New Project and click on the plane frame and give the file name as RCC column 1 and select the units as meter and kilonewton. Click Next and click Add Beam and click on Finish. Now, as usual, you will get the grid pattern, but click on the setup and give the file name here as RCC column and client name is typed as usual, and all these details is it's good to fill it up. So then you click on geometry once you enter the details, and you close this, the snap node beam, close it, and it is a column, means a vertical member. Column is a vertical member, whereas beam is a horizontal member. So in the horizontal member, we have given the x coordinate, whereas in the vertical member, so you have to give the y coordinate. That is, the x is 0. Of course, the first point, that is the starting point coordinates are 0, 0, 0. And for the node 2, that is the other end of the column, so the x coordinate is 0 and y coordinate is taken as the height of the column, which is 3.3, and z is 0. And similarly here, the beam means it may be a column or a strut or beam. So here for node 1 it is given as 1, and for node B it is given as 2. Node A is 1 and node B is 2. Now you can see the vertical column is generated here. To see the node numbers, you have to click on Shift N 1 and 2. So once the nodes and beam are created, you click on General tab and give the property here. So that means the cross section of the beam. Click on Define. You can give either the circular column or a rectangular column. So I'll take a rectangular column, but I'll give the dimensions as a square. So I'll give as 0.45, the size of the column by 0.45, or you can give 0.4 by 0.4, 400 mm by 400 mm, and click on Add button and see the material is concrete and click on Add. Close it, and rectangular section, that is the square section, is added here. And now you have to assign this cross section reference 1. So use the cursor to assign it, assignment method, click on assign and click on the column. So this shows R1, which means the reference section 1 is attached to this column. After this one, just go to the supports. So where you are having only fixed end support, one end is fixed. So create the support, a fixed end, click on Add, and select the support S2. This is the fixed end support what we have created, and we have to assign it and use cursor to assign. This option you have to take it and click on assign and click on node 1. So this is the one. So other end is free. So just leave it like that and click on close. And now go to the load definition. And as usual, you have to click on the load case details and click on add. And in the primary, you take it as dead load and load case 1 and click on add. Close this button. Load case 1 is added here, and select the load case 1 and click on add to add the axial load, that is the member load. And there is also self weight. Click on self weight and the direction is Y. So click on add. The self weight is added and take the member load. And in the member load, you have to take the concentrated force. So this is the axial load. So the value of this one is 3000 kilonewton. And since it is, the axial load, don't give any values, either D1 and D2, just leave it. And it will ask for save, just save it. And direction is GY, click on add. So that is added and click on close. So the two loads are added here. As usual, we have to assign these loads to the column. Click on self weight and select the assignment method is assign using cursor. So click on assign, click on this one. So the self weight is attached and you see the green square box. So now, so select this concentrated load Y and assign to view. Now use cursor to assign option. You have to take it and click on node 2. So it is showing upward force. Why? Because you have not given minus sign. So double click on this one, load, and here you add minus. So minus sign is added, which means that the load is acting downwards, not the upward. So click on change, click on close. So now the load is applied from the top, that is from the top end of the column. So assigning is over and I close it. So now come to this material. Already we have assigned the material concrete and just assign to view, click on this one and say OK. So just to see the loads, you just click on these loads and you see the green arrow, which means the load is applied here, and you can see the value of the load, shift and V. You can see here 3000 kilonewton. Okay. So once you apply all these properties and supports and loads and material, assigning is over. The next step is you have to go for the analysis. Click on the analysis and in the perform analysis tab, you select all, click add. So that is added here. You close this window and go to the analyze menu. In the analyze menu, you select the run analysis, click on this one, and of course you have to save it. So now the analysis is performed, and now you will see the performance. The analysis have been carried out. You can see 0 errors, warnings. That means everything is okay. Sorry. Now you can click on this output file to view the output of the analysis. Otherwise, you go to this post-processing mode and finally we can see the output file. So since there are no warnings and no errors, so it is okay. So it is better to go for the post-processing mode. Select this one and click on done. So load case is selected and say okay. Now this is the one, and Now what you have to see is you have to find any reactions here. I can see here the reaction and all. Okay, and there is no bending moment because it is axially applied load, so it is pure compression. And now you can do the design part. For that, you click on this modeling tab and click on design tab, which is the last tab of this modeling mode. So we have carried out sequentially setup, geometry, general analysis, and then finally design. So in this one, you have to select the concrete material here. So now then select the current code as IS456 concrete code for the design of beams and columns. And here you have to select the parameters. So whatever the parameters you want, you have to select them and click these arrows so that you can, you know, select the all these parameters, whatever required. So I want to select the compressive strength of concrete and press Control key and select the main reinforcement yield strength, secondary, and then diameter of the bars, main reinforcement and secondary reinforcement, and minimum size of bars. And you have to select here uh, the reinforcement, either select either tied or spiral reinforcement for columns. This you have to select and click on this single greater than symbol so that only selected parameters will be added to this window, and click on OK. And after that, click on define. So here you have to give the characteristic strength of concrete. It is 25,000. Click on add and give the FI values. So if I want to give the 500, FE 500, you can give this or okay. Click on add. Now FI also you can give it as FE 500. Add and maximum diameter I've taken as 25 mm, or you can take 20. Click on add. Maximum secondary is 12 and minimum diameter of the bore is 20. Add minimum secondary is 8 mm. The reinforcement here, you have to select that tiled column, click on add and close it. And after this, you have to click on this. After select parameters, define parameters, click on commands, select the design beam and click on add. Sorry, you have to select the design column. It is a column, so you have to select the column and click on add and select the takeoff. So here it calculates the volume of concrete and weight of steel. So click on add it and close the button. And here you have to delete this part. This is design beam is added. So by overlook, so you select this one and press the delete key. So it will be deleted. Okay. So design column is there. So now what you have to do is you have to assign all these parameters to the column. Select all the parameters and use the assignment method as assign to view and click on assign, click on as. Similarly, do this assign to view and assign. So you can see the green tick mark for all the parameters once you have assigned it to the column. So So this is the way how you have to carry out the assigning the parameters before you're starting the design part. So reinforcement, we have selected the side reinforcement. Spiral is selected for the circular column. So, so all the parameters are assigned. So you can see the green ticks. Now the option is you have to go to the analysis and run analysis. This will calculate both the analysis and design part. Click this one. And the analysis is carried out, and you can see the zero errors and warnings. Now you can see the output file. Click on output file and click on done. So you can see everything here, the name, job name and client, and all the details what you have given. And you can see the reactions and the movements. And this is the click on the concrete design. You will see all the parameters what you have given here. And you can see the length of the column is 3.3 and cross section is 400 by 400 and steel is Fe 500 and M25 and cover for column is 40 mm and it is a short column. I can see the total steel area and the concrete area is given here and main reinforcement is provide 16 parts of 20 mm diameter which is 3.14%. It is equally distributed so on all the four faces and the tire reinforcement is 8 mm dia at 300 mm center to center and you can see the quantity of concrete is 0.5 and weight of steel reinforcement is 1,332 kgs. It's almost 1.5 ton. So this is the way how you have to do the analysis and design part and now you can calculate the number of cement bags and the quantity of fine aggregate and coarse aggregate. And also you can calculate the cost of the structure for constructing a column of height 3.3 meters. So this is the way how you have to carry out the analysis design. And also you can use this data in the calculation of cost of the structure. So once it is done, you can save this file, click on print and save it in a PDF format. There are 6 pages, so click OK. And give the file name here as RCC column and analysis and design. Click on save. So that file is saved in the PDF format and close it. And if you want to see the reinforcement details, the drawing, double click on this column. Now you can see the length and cross-section dimensions 0.4 by 0.4 and shear bending, deflection, and concrete design. You can see here there are 16 number of bars and design parameters F500 and M25 concrete and percentage of steel is 3.14%. The bar sizes are given here. So once it is done, just take a print out of this drawing, just click on print and it will be saved in PDF format. So what I'll do, I'll give the same file name, RCC analysis and design reinforcement details. So this is the file name I've given and both files are in PDF format. So you can take a print out and submit it as an assignment, and now you can close this window. And this is the way how you have to carry out the analysis, and you can see all these uh, sequential steps what we have followed, and also you can see the uh, you know the output file, and if you want you can do the the corrections to the in this one edit input command file. You can see here in the edit menu, click this one, you can see the input file where you can change the input parameters. So you can see here the job name what you have given, and all these things, and you can see this is the height of the column. So we have given 3.3. If you want to make it as 3, you can do editing here, or 4 meters, or whatever the height of the column you can give here, and also you can change the the values of concrete. So all these things you can change here, and click close it. And if you change any parameters, you can save it. That same will be applied here. So this is the way how you have to carry out the analysis and design. And in the end of this topic, so you can see some of the exercises what I have given in the end of this exercise as carry out the analysis. The size of the column is given, and length is given, and the grade of concrete and steel and load. So use these values and carry out the design of the column. So hope you have learned these procedure. So practice many problems as you can, and learn perfectness. Okay, thank you.